Welcome to Mrs. Bibb's Algebra 1 Honors Class. We're on week 21. Summer is almost here. It won't be long. So let's dig in. We're getting started on some concepts that you really need to master for Algebra 2. Make sure to fill in your table of contents. Make sure that you complete your weekly warm-up. And let's just dive right in. You'll need those student journal pages that are listed on the PDF. I can't see them for my little toolbars that are there, but you can see it, and if you need to pause to get your student journal page, go right ahead. Okay, so I'm going to match the factored form to 19. I can see it now. I moved it over. I'm going to match the factored form with the standard form. Now, I want to show you a trick. You do not actually have to multiply the whole thing to match the factored form and the standard form. Now, one of them we may have to, because look, your constant is -2. Your constant is -2. Your constant is +3, +6, and -3. So really, all we have to look at to match, for the most part, is this number times this number. Let's do that first, so we can do some matching that will help us. You want to pause and see if you can match them. So with this first group, -1 times -3, lowercase a would go with C. This is lowercase a. So those match each other. -2 times -3 is +6. So capital D goes with lowercase, oops, and I just wrote my B backwards. Goes with lowercase b. For the next one, this one gives me a product of -2, and so does D. So lowercase c and lowercase d we'll come back to in just one moment. And then +1 times -3, that is -3, so that's lowercase e. Now, what we need to do, and I'll do C and D down here at the bottom, I'm going to do x times x minus 2 plus 1 times x minus 2. That'll give me x squared minus 2x plus x, oops, no, that's right, plus x minus 2. When I simplify, I get x squared minus x minus 2. X squared minus x minus 2 goes with capital A. So capital A is matched with lowercase c. And let's check letter D. We're going to do x times the quantity x plus 2 and -1 times the quantity x plus 2. So x squared plus 2x distributing minus x minus 2. So I get x squared plus x minus 2, which is letter B. So capital B is matched with lowercase d. Can you tell which one of those, and we'll just use the capital letters here, can you tell which one of those would be matched with number 1? The only one that has a 6 is capital D. So capital D goes with number 1. Let's skip down to number 3. X squared minus x equals 2. I need to move that 2 over here, and that would be x squared minus x minus 2. Which one does that match? That matches letter A. So I took care of A, I took care of D. For number 4, I could subtract the 2 and distribute at the same time. X squared plus x minus 2 equals 0. X squared plus x minus 2, so capital B for number 4. And then for number 5, I could add 3, and I'd have x squared minus 4x plus 3 equals 0, and that is letter C. So we know right now that this is letter E. Now, there's a way mathematically to work it out, and I'll show you. You would write down x minus 1 twice, you would distribute, and then you would combine like terms. And of course, you're going to have to subtract that 4 once you do that. I don't expect you to show that work today for this, but that's what you would do. You would distribute your x to x minus 1, and then you distribute your negative 1 to x minus 1, and then you would subtract 4, and you would get x squared minus 2x minus 3. Moving on to the next thing. I want you to go to your textbook and write down the definitions for these terms listed here. I found the page number for you, page 378, 379. It's also in chapter 7, if that'll help you find these on the PDF faster, because you may not have your textbook handy, and you can just look on the PDF to find those definitions. I do want to add one thing about repeated roots. I have seen repeated roots on a standardized test referred to as a double root. So you may want to remember a repeated root is also referred to as a double root. When you're solving using the zero product property, and this really won't apply this in this lesson, but you have to make sure that your equation equals 0 before you can solve using the zero product property. So be very careful with that. And the zero product property just means if you have something that looks like this, you have two factors. You have x is a factor, and you have x plus 2 as a factor. You set each factor equal to 0 and solve. Let me show you. My x would represent the a in that general rule, and my x plus 2 would represent the b. So then what you would do is you would set a equal to 0, set b equal to 0, and then you would solve. So to solve this, I would set x equal to 0, x plus 2 equal to 0. The first one is solved, x equals 0. The second one I solved by subtracting 2, x would be negative 2. So for my little example that I have, my solutions would be negative 2 and 0. Looking at exercises 1 through 12, all of these are equal to 0. So this is really quite simple. You're going to take all of the ones, all of the factors, and set them equal to 0. I'm going to do just like I did on the last one. I'm going to talk about number 7 though. So you're going to set all of the red ones equal to 0, and then you're going to set all of the blue ones equal to 0, and you're going to solve. Please remember as you're doing this that this is called the zero product property, and you will see me refer to this as ZPP, zero product property. That just means that you set each factor equal to 0 and you solve. So I'm going to set x equal to 0, x plus 5 equal to 0, and solve. X equals 0 is solved. X plus 5, I would subtract 5. So x would be negative 5. My two solutions are 0 and negative 5. Why don't you pause the video and try number 2 and number 3. Now, I have solved number 2 and number 3. I set each factor equal to 0, and I solved. I believe I lost my, yes, so 0 divided by 5 is 0. I don't know what happened to that 0. Now, let's look at the next row. I'm going to set each factor equal to 0. The next row isn't as easy. It's not difficult, but it isn't as easy. Let's see. I think I'll do number 6, and then I'll let you do 4 and 5. So I'm going to set the red factor equal to 0, and the blue factor equal to 0, and I'm going to solve. Subtract 3, divide by negative 5, so S would equal positive 3/5. Add 3, 5s will equal positive 3 divided by 5. S will equal positive 3/5 also. Is that correct? Yes. And this is one of those repeated roots, or what's called a double root. And you do not have to repeat it. You may just say 3/5 is your answer. So why don't you pause the video, try number 4 and number 5, and let me know, of course, if I make any silly mistakes. Check your answers and check my answers to number 4 and number 5. Please let me know if you feel like I made any mistakes. I tried to be careful, but sometimes even being the most careful, I do tend to make a mistake sometimes. I'd like for you to try 8 and 9 after you check 4 and 5. They're the exact same thing. We're going to solve them the exact same way, and then we'll discuss number 7 after that. There's the answers to number 8 and number 9, and again, let me know if I made any silly mistakes, because we know it happens. I just set each factor equal to 0 and solved each linear equation. For number 7, you may rewrite it to look like this, because that's what we would do if we were multiplying. And then you may go ahead and just do the process that we've been doing and set each factor equal to 0. But if you realize that when you solve, you're going to get the same answer, you're going to get 3, then you may just do one of them. And again, this is one of those repeated roots where 3 is the only answer. And it's also called a double root. Now I'll just give you a preview of the future. When you graph these, this is where these graphs cross the x-axis, and when you have a repeated root, it just touches the x-axis. So when you have two solutions, let me draw two little graphs here. When you have two solutions, it crosses the x-axis in two places. So we're finding the x-intercepts. It's where y is 0. When you have one solution, it just touches the x-axis in one spot. You only have one y-intercept. Okay, let's go on to the next page. Now this is definitely just a polynomial in factored form. I could not get that straight last night, but maybe I could get it straight now. Okay. It's not a quadratic in standard form. It's just a polynomial. So remember, this means I have two of these, which means this is just a double root or a repeated root. I only have to solve one of them. So I'm going to have 3 solutions here. One is a double root. I'm going to have 3 solutions here because I have 3 separate factors, and 3 solutions here because I have 3 separate factors. I'm going to set these all equal to 0, and then I'm going to have you pause the video and solve these as well. So set each factor equal to 0. I'm going to run out of room. I hope not. I'm going to try my best not to. So the next one, I may have to put that one down here because this is going to run into this one. I'm going to put it down here, the third one. -2 minus 3m equals 0. Okay, so if you will pause the video and solve each of those equations, then we'll come back and compare our answers. Here's my solutions. Remember for number 10 that -4 is a double root, so technically it occurs twice. If you had written this, that would not be incorrect. And remember, the graph touches the x-axis at -4, and it crosses through at -1. That will help you in the future when you start thinking about graphing these polynomials. Number 11, -2, 0, and 2. So the graph of that function crosses at -2, 0, and 2. Crosses the x-axis. The same thing for number 12. That graph of that function crosses the x-axis at -12, -2/3, and 4. So hopefully I got the correct answers and you also got the correct answers. Please reach out to me if I have done something incorrect or if you have a question. Moving on to the next page. Now we're going to begin factoring. And the first step in factoring is taking out the greatest common factor. And by greatest common factor, I mean the largest number, so numerical factor, and variable factor that each of them have. So for your numeric factor, you're looking for the biggest number that will divide into all coefficients evenly. You may want to write that, biggest number that will divide into all coefficients evenly. I'm going to abbreviate that. And then for your variables, you are really looking for, number one, all your terms, all your monomials within your polynomial all have to contain that variable, and you choose the smallest exponent, because that would be the least they have in common. Now, what in the world do I mean by that? Let's look at 13. Oh, and one more thing. I want to define the word factor. Factor just means to undo the distributive property. That's what it means. Undo the distributive property. So all of these I'm going to have parentheses, all of them. That's my final answer. It's like we're unsimplifying. We're going to have parentheses and we're going to have something in front that would have been distributed to get the given answer. So let's see what that would be. When I look at 6x squared plus 3x, looking at their numeric factors, so looking at 6 and 3, what's the biggest number that will divide evenly into both 6 and 3? And students will say 6, but remember, we're talking about dividing into. So 6 does not divide into 3. 3 is your biggest numeric factor. The second thing you ask yourself, do both of these terms have an x? Yes, they both do. So my greatest common factor will also contain an x. Now, look at your exponents. I have a 2 and I have a 1. What's the smallest exponent of those two? Well, to the first power. So that's what I'm going to have on the outside. To find what goes on the inside, you simply divide each of these by that common factor. And you have to have an answer for each of them. This has to have a plus sign because I need to be able to distribute to get what I started with. That's how you check your answers, mentally distribute. So 6 divided by 3 is 2. X squared divided by x is x to the first power. For the next term, 3 divided by 3 is 1. Let's see if I need to write down that 1. X divided by x, 1 minus 1 is 0, so yes, I need that 1. Now mentally check, mentally distribute. I'm going to draw some red arrows and then I'm going to erase them. So 3x times 2x, is that 6x squared? Yes, it is. 3x times 1, is that 3x? Yes, it is. I think I'll just leave those arrows. So factored, 6x squared plus 3x factored turns into 3x times the quantity, 2x plus 1. Let's do number 14 together. The number 4 and the number 20. What's their greatest common factor? The biggest number that will divide into both of those evenly. And that is 4. 4 is the greatest common factor. Y to the 4th and y to the 3rd. They both do have a variable y. And what's the smallest exponent on both of those? A 3. So 4y to the 3rd is my common factor. Now I'm going to divide each of these by 4y to the 3rd. 4 divided by 4 is 1, and I may or may not have to write that down. Y to the 4th divided by y to the 3rd is y to the 1st power, so I did not need to write down my quotient of 1. Negative 20 divided by 4 is negative 5. Y cubed divided by y cubed makes those y's cancel out. 3 minus 3 is 0, so I do not need to write down a y. And this is my answer. Check mentally again. 4y cubed times 4, is that 4y to the 4th? Yes. 4y cubed times negative 5, is that negative 20y cubed? Yes. So that's the answer. Let's look at the next one. 18u to the 4th and 6u. 6 is the biggest number that divides evenly into both of those. And then do they both have a u? Yes. And the smallest exponent is to the 1st power. I'm going to divide each of these by 6u and put that answer inside the parentheses. 18 divided by 6 is 3. U to the 4th divided by u is u to the 3rd. 6 divided by 6 is going to be a negative 1. Do I need to write it down? Yes, because u divided by u is also a negative 1. So 6u times the quantity 3u cubed minus 1. Number 16. Numerically, 7 and 2 do not have a common factor. So I don't need a numeric greatest common factor. But with variables, I have a z in the first term and a z in the second term. So z is their common factor. What's the smallest exponent between the two? And that would be a 6. So z to the 6th is my greatest common factor. I'm going to divide each of these by z to the 6th. 7 divided by 1, because that's the coefficient out there, is 7. Z to the 7th divided by z to the 6th is z to the 1st power. 2 divided by 1 is a positive 2. Z to the 6th divided by z to the 6th reduces away to 1, so 7 to the 6th power times 7z plus 2 is the answer. The next one, 24 and 8. What's their greatest common factor? Well, that would be 8. Do they both have h? Yes. What's the smallest exponent they both have to the 1st power? Divide each of these by 8h. 24 divided by 8 is 3. H cubed divided by h is h to the 2nd power. Then I'm going to have a plus sign. What's 8 divided by 8? That's 1. And h divided by h cancels out, so plus 1 is what goes there. And again, you can check these by distributing. One more. What's the common factor between 15 and 45? And it's okay if you have to think about it. They do have 5 in common, but they also have 15. So 15 is the greatest common factor. They both have an f, so I'll put an f here. And the 1st power is the smallest exponent, so it's f to the 1st. Now I'm going to divide both of these by 15f. I'll have 15 divided by 15 is 1. F to the 4th divided by f is f to the 3rd. 45 divided by 15, that's a negative, is 3, and f divided by f cancels out. So 15f times the quantity f cubed minus 3. So that was a crash course in finding the greatest common factor and factoring out the greatest common factor. Please, please, please remember, the word factor means to undo the distributive property. This is a very, very, very important concept for Algebra 2. Next, we're going to solve each equation. And remember earlier when I said that to solve, it has to equal 0? Well, 19, 20, and 21 equal 0. They're good. 22, 23, and 24 do not. So that would be the first thing I would do, is make these equal 0. And I would always move to the squared term. So that's why you could see on 23, I moved the 22s to the squared term. So I'm going to have 6x squared plus 72x equals 0. I'm going to have 0 equals 11s squared minus 22s. And then I'm going to have 7p squared minus 21p equals 0. Now what I would like for you to do is to go through and go through and factor every problem. And I'll do the first two with you, then that way you can hopefully do the rest, and we'll check our factoring before we solve. So to factor, we look for a greatest common factor. 6k squared and k do not have a numerical factor in common, but they both have k. So I'll write down k, divide them each by k. 6k squared divided by k is 6k. K divided by k is positive 1. So that's factored, and I'm going to keep my equal 0. Number 20, I want to factor this as well. I've got an n in common, and 35 and 49 both have 7, I believe, in common. So 7n is my greatest common factor. Divide each of these by 7n. So I would have 5 minus 7n, and that equals 0 as well. So if you will pause the video and factor 21, 22, 23, and 24, and we'll come back and check that factoring, and then we'll do the zero product property. Because it says to solve these equations, and I have quadratics, I have to use the zero product property. It has to equal 0, it has to be factored completely, and then you use the zero product property. So I'm going to save the dividing for you to see. For 21, 4z was the greatest common factor. So to get that z plus 13, I divided each factor by 4z. For 22, 6x was the greatest common factor. So to get x plus 12, I divided both of those factors by 6x. For 23, 11s was the greatest common factor. So to get the s minus 2, I divided both of those factors by 11s. And then for 24, 7p was the greatest common factor, so I divided both terms by 7p to get p minus 3. Now we're going to do like we did in the beginning, and we're going to set each factor equal to 0 and solve. Let me do the first one with you, and then we'll check it, and then we'll pause, and we'll each do the rest of them and come back and check them together. And I hope that's all. So 0 is one answer. Subtract 1. 6k equals negative 1. Divide by 6. K is negative 1/6. The two solutions for number 19 are negative 1/6. Look, I wrote 1/2 and I said 1/6. Negative 1/6 and 0. So if you'll pause the video and solve the other ones, and then we'll come back and check. There are the answers for the rest of them. Number 20, I got 0 and 5/7. Number 21, I got negative 13 and 0. Number 22, I got negative 12 and 0. 23, I got 0 and 2. And 24, I got 0 and 3. So hopefully I got them all correct, and you did as well. If I did not, please let me know. If there's something you don't understand, please reach out and talk to me so that we can work things out. I think I have one more thing to talk about. I have two more things to talk about. We need to do this problem, and then we need to do an example like one of your homework problems. So let's look at this problem. A boy kicks a ball in the air. The height y in feet above the ground of the ball is modeled by that equation where x is the time in seconds, so x is the time in seconds since the ball was kicked. Find the roots of the equation when y equals 0. So we're going to put 0 in for y. 0 equals negative 16x squared plus 80x. So I'm going to solve this to find the roots. That's what you're doing. The roots are where the graph crosses or touches the x-axis. The roots are also known as the solutions to this equation. So we're finding the roots or finding the solutions. and I'm going to factor out that negative 16. Divide both of these. Oops, and I saw something else I need to factor out. See that? See how easy it is to make a little mistake? I think I was focused on trying to make sure that I could write in that little white space, but I'm going to switch to red, and I'm going to make this bigger, and I believe you'll be able to see it on that blue background. So I'm going to factor, whoa, yes you can. I may have to make that smaller. I'm going to factor out negative 16x. Yeah, let's make that a little smaller. See if this will work. So I'm dividing each of these by negative 16x. Negative 16x squared divided by negative 16x is just x. Positive 80x divided by negative 16x is going to be negative 5. Now to solve, I'm going to do the zero product property. I'm going to set each factor equal to 0. So I'm going to put negative 16x, set it equal to 0, and x minus 5, set it equal to 0. Divide by negative 16, x will be 0, add 5, x will be 5. Now, what that means is this, first of all. And hey, I got a graph there. That was pretty cool. If I were to graph this parabola would cross the x-axis at 0, 1, 2, 3, 4, 5, and at 5. So the graph would look something like this. Now, of course, when we're talking about kicking a ball, then I'm going to erase the areas that would not apply. This would not apply, nor would these, right? Because if you're kicking a ball, the height of the ball, which is what that green represents, would never be in the negative areas. So what do, oopsie, I can undo. What do 0 and 5 stand for? Well, 0 is how far, let's see. The roots are 0 and 5. 0 is where the boy first kicks the ball and the ball is laying on the ground. And then 5 represents how far away from the boy the ball was when it hit the ground. So this ordered pair is 0, 0. This ordered pair is 5, 0. This 0 tells me that the ball is on the ground. And the y-coordinate tells me the ball's on the ground. Now the x-coordinate is also the time in seconds. What does this 5 tell me? 0 would be 0 seconds. 0 seconds, the ball is 0 feet off the ground. What's that 5 tell me? How long is the ball in the air? That 5 tells me that the ball was in the air for 5 seconds. And I know that's the first time you've ever seen anything like that. So it's okay. We will do many of these. And it's a great preview of what you're going to see in Algebra 2 Honors. One more problem, then I think we're finished. Okay, so this problem is going to be similar to the one that you see on page 364, number 61. And it's fancy, and it tells you it's a patio, and there's a pool and a hot tub, but I'm not going to go that far. I want the area of the yellow region. So that's what I want. The area of the yellow region. I would write this down so that when I assign the week 21 practice, you'll have this somewhere for you to look at. So if there's space somewhere in one of the student journal pages for you to write this down, I would write this down. And I pause the video and draw the picture. So it says, write the polynomial in standard form that represents the area of the patio. Well, I'm actually going to have to write out what it would take to find that yellow air region. Okay, so first of all, I need to know what the measure of this whole side is. And I hope you can look at it and see the whole side is 7x feet. Because I need to know the area of the whole thing. And we're talking about all rectangles here except this up here is a square, but we still find the area the same way. So remember, the area is length times width. So let me explain how I got 7x. The distance from here to here is 4x. I need this distance. Well, what is this distance? It's 3x. So 4x plus 3x is 7x. Okay, so the whole entire area would be, this is letter A, 7x minus 5 times 7x, length times width. Then I'm going to take away, to have the yellow area, I'm going to take away the area of the bottom rectangle, which would be length times width, so 5x minus 10 times 3x. And then I'm also going to take away the area of the little tiny square up in the corner, which would be x times x. Whoa. I'm hitting my little toolbar on the side. When you record, you can't see the toolbar, so I'm just hitting that toolbar on the side. So x times x, and I'll fix that x in just a second. So we all know that's an x there. I'm going to distribute my 7x, my 3x, and then I'm going to do x times x. So I'm going to do that. I'm going to have 49x squared minus 35x. Then I'm going to have negative, because this is a minus sign, negative 15x squared. And then I'm going to have positive, because I've got negative 3x and negative 10. So I'm going to have positive 30x. And then I'm going to have minus x squared. Then to finish out letter A, I need to simplify. 49x squared and negative 15x squared is 34x squared, I think. And again, please tell me if I do anything wrong. Negative, oh, I got another x squared. See, there we go. So I got one more. That would be 33x squared. I'm going to make it erase smaller. 49x squared minus 15x squared is 34, minus one more would be 33x squared. Then I have negative 35x and positive 30x, so that'd be minus 5x. So that would be my answer to letter A. Your answer will be similar to that. So that's how I do A. Now letter B in the textbook says, the patio will cost $10 per square foot. Determine the cost of the patio when x equals 9. What I'm going to do, this would represent the cost of the patio, 33x squared minus 5x. That number represents the cost of the patio, 33x squared minus 9x. What I would do is substitute 9 for x. So 33 times 9 squared minus 9 times 9. Do order of operations, so do your exponent first. 33 times 81 minus 9 times 9. I hope I said 33 times 81. Multiply 33 and 81. I'm going to pause and do that. I got 2,673 minus 81. So that has to be 17. That would be 5. So that would be 9, 5. So 2,592. Now I got to go back and look. And it says the cost will be $10 per square feet. So that would be $2,592 just for the patio. So that's how you're going to do number 61. Here's your example. I'm sure we'll have time to work on it in class, so you can get me to look at it for you. But this is your example to help you. You have to find the area of the entire region. I'll highlight that in blue. So the area of the entire region, and then subtract away the areas of the other two region. This bottom number, 5x minus 10 and 3x, that represents like the bottom right-hand corner. That's this area. And then this represents the top right-hand corner. If you take those two away, the green and the black away, you're left with the yellow area, and that's what it wants, is the area of the patio. Hope that helps, and I hope you have a wonderful day.